David Smith here with another flipped classroom math video. A few tips before we start. Remember that you can speed up or slow down the playback if that helps you follow along. You can also pause the video at any point to catch up with your notes or to try the problems before I explain. Lastly, you could turn on the captions and follow along with my words on the bottom of your screen. Today's topic, theoretical probability. So far in our chapter, we've been discussing probability through experiments, situations that we don't know about, so we do a little experiment, gather some data, use that data to calculate probabilities based for the whole population or the whole sample. So with theoretical probability, we calculate probability based on what we know about a situation. We don't gather data. So that's what this is, calculate probability based on what we know about situations. So we need certain types of situations to be able to do this. Asking questions about preferences for large groups of people, we need experimental data to do that. During election season, you see people doing polls all the time, and polls are used to predict the outcome of an election. It's the same kind of thing. So with theoretical probability, we deal with things like coins and dice because we know how they behave, and we can make certain assumptions about that. So here's a little if-then statement that gets us in the door for theoretical probability. If a sample space has n equally likely outcomes. And so what that means is with a coin flip, we're assuming that it's equally likely that it lands heads or tails. Or with the roll of a die, that one of the 6 sides is just as likely as any of the other 6 sides. So if the sample space has n equally likely outcomes, then the probability of each outcome is just 1 over n. So let's do a couple quick examples for that. Coins. 2 outcomes, head or tails. So the probability of heads, there's a little bit of notation there that we're going to use, is just 1 over 2 or 50%. With dice, we have 6 equally likely outcomes. So the probability of rolling a 5 is going to be 1 over 6, which is 16.7%. Okay, let's formalize our definition for calculating probabilities. The probability of E, this is some event E, we're just calling it E, it could be a bunch of things. It's the number of outcomes that correspond to E over the total outcomes in the sample space. So that might seem like a lot of words. Let's put it into example. This is a little bit more general than what we did on the last board, but you'll see why. So we're going to go back to rolling a die. Remember, a 6-sided cube with numbers 1 through 6 on each side, each option equally likely. So what's the probability of rolling a 3? We kind of did this one with a 5 a minute ago. This would be 1 out of 6, or 16.7%. Okay, pretty straightforward. Now we're going to say probability of odd. So this is where we get into the outcomes corresponding to event E. In this case, the E is odd. So how many outcomes do we get that are odd on a die? That's 3. We have a 1, 3, and a 5. So there's 3 outcomes that are odd. Total number of outcomes is 6. That's going to be 50%. Okay? Now let's take a look at this one. This is the probability of rolling a 2 or a 4. Okay, so 2 outcomes that correspond to that. That's going to be 2 over 6, which is 33.3%. And then our last one is getting a little more complicated. What's the probability of rolling even or a 3? So there's 3 even numbers, 2, 4, 6, plus the 3 means there's 4 outcomes that correspond to this event. So that's going to be 4 over 6, which equals 66.7%. Last example. We're going to take a look at tossing 3 coins at the same time. Before we start getting into the probabilities, take a look. Here's my sample space. This is written in the list. These are all the possible ways we could get that. The first coin is an H, the second coin is a head, the third coin is a head, and so on. And we talked about how to be sure you've got the right list. So now, if you want, pause the video right now. You have enough information to calculate the probability of getting 3 heads or of getting at least 1 head. So go ahead and see what you get. Okay, let's take a look. This is going to be the number of outcomes that correspond to what we're looking for. So there's only one way to get 3 heads. That's this one. The rest of them have at least 1 tail. So we've got 1. Now what's the number of outcomes in our sample space? Well, here they all are. There's 8 different ways those 3 coins can land. So that's 1 over 8. At least 1 head. So how does that look? Well, there's only one case where you don't have at least 1. Every other one has 1 or more heads. So that would be 7 over 8. Get out your calculator, figure out what that is. Okay, 1/8 is 0.125, which is 12.5%. And then 7/8 is 0.875, which is 87.5%. Now that you've finished, write down any questions so you can bring them to our next class and get some help. Remember that you can always watch the video again to improve your understanding. If you enjoyed it, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.